Hello, welcome to our first Algebra 1 class online. I hope you're all doing well, and I know you're probably not looking forward too much to math at home. I know there's some concerns there, but I think we can make this work. I think that the first unit we will mostly work on review. We've been working on radicals for quite a while, but they're very important. They will see us through Algebra 2 and be very important in geometry as well. So the more practice we get with them, the better off we're going to be. I do have one lesson this unit, and then we'll start some new things next time. Make sure that you are reading the notes that I sent home to you in your packets. I've tried to do a little explaining there. Remember that you have information in your books, all right? Each section, read through it very carefully. Take note, study the examples, and sometimes you'll need to look back at previous sections to remind yourself of information that you should already know, but you may have forgotten. It's all in there. If all else fails, then contact me with my schoolworks, and we'll go through it and see what else we can do to help you out with that. Okay? If you can't get every problem, it's okay. It's not going to be the end of the world. We want to get the general concepts so that we'll have something to build on when we come back. Whenever we come back. Okay, so I do want to go over one idea here very quickly. You were supposed to memorize the Pythagorean Theorem and the distance formula. That was your assignment when we were still in school. And just because you're not in class to have the quiz on it, they're still very important. Make sure that you have them memorized. Write them every time you do a problem. Write them in their general form and then put the numbers in. I'm going to run through the Pythagorean Theorem very quickly, and then we're going to look at the distance formula in a little more in depth. Okay, remember that the Pythagorean Theorem, can you zoom in a little bit more on this? Okay, is just for right triangles, only right triangles, and keep in mind that C, the hypotenuse, okay? Always put your C for the value of the hypotenuse. Never put A or B over here. All right, so let's just put some numbers in here. Let's assume that I know that A is 3 and B is 4, and I want to find what C is. First, I'm going to write my formula. Since C is what I'm looking for, I want it to be equal to C. Okay, so we're going to put in our numbers. 3 squared plus 4 squared is equal to C squared. This gives us 9 plus 16 is equal to C squared, or 25 equals C squared. In order to solve here, we need to take the square root of both sides, getting 5 is equal to C. All right, and I can double check it then. 3 squared plus 4 squared is equal to 5 squared up here. Now, occasionally you may get an answer such as the square root of 32. Just like we've been working on it, it must be reduced. Square root of 16 times 2, which will be 4 square roots of 2, and that's how your answer should be. Here it came out perfectly. That's always nice when that happens, but occasionally we'll have something like this, and we want to take care of it appropriately. Don't ever leave an answer like this when it can be reduced. All right, now, if for some reason we knew A and C, but not B, so we're just going to take this 4 out of here, use the same numbers, and this time I know that C is going to be equal to 5. We'll stick with the same values. Then I'm going to start with my A squared plus B squared equals C squared, but since I want to know B, I need to isolate the B squared, okay? So we're going to have A squared plus B squared is equal to C squared, and I'm going to move the A squared to the other side by subtraction. So B squared will be C squared minus A squared. Okay. Now I'm going to be able to put my values in because A is 3, C is 5, so B squared will be equal to 5 squared minus 3 squared, or B squared equal 25 minus 9, which we know is 16. Again, taking the square root of both sides, B is equal to 4 in this case. And again, it came out exactly, so that's okay. But notice, when I wanted C, I kept C by itself. When I wanted B, I kept B by itself. That's an important step, and it will keep us from getting confused later on. Okay? Now the next thing that I want to look at is the distance formula. And the distance formula actually comes from the Pythagorean Theorem. Okay, so it's useful to understand where it comes from. That will help us to use it later on. So if I think about the Cartesian plane, it's been a little while since we've seen that, but let's just put some imaginary points on here. I'm not going to do the entire graph, but we're going to put a point here at 1, 1, and another one over here at, I need my point, 6, 1. Okay, now if I want the distance between these, they're in a horizontal line, so if I just run right across here, all right, I would have counted over 5 spaces, or 6 minus 1. All right, so the distance here would be 5. We'll get into this more in geometry, but it's just a little illustration here. Now assume I have another point here at 1, 7. Okay, since this is straight up and down a vertical line, then I could find the distance here by subtracting the y values. 7 minus 1 would give me, in this case, 6. So we see we can find the distance on the horizontal scale or the distance on the vertical scale very easily. But when it comes to finding how far it is from 1, 7 to 6, 1, we don't have a method that works. We can't just do that by subtraction. But if you'll notice, what we've created here is a right triangle. We know the B, if you will, just like we did here, and we know A, if you think about it, and we would be finding the hypotenuse. Okay, so the formula that we had, the distance formula that you were supposed to memorize, D is equal to the square root of x2 minus x1, and that quantity is squared, and I'm adding to that the, I don't know where that came from, y2 minus y1, and this is being squared as well. So if you think about it, the difference between the x values, the 6 and the 1, gives us the distance on the horizontal, okay, which is basically 5, and we're squaring that. We're adding, this is the distance on the y, from 7 down to 1. So that gives us our 6, and that's being squared. So a squared plus b squared, if you will, is c squared. Now we're using d for distance, but we don't want d squared, we want d. So our final step is to take the square root, which then would give us, I don't think I put values that are going to work out very nicely, but we would be able to find our value in that regard. Okay, so if you're ever taking a test, a quiz, some big ACT or something, and you suddenly can't remember where all your minuses and your pluses and your squareds go, you can think about it logically. The difference between the x values gives you your horizontal length. The difference between the y values gives the vertical length. We add them just like we do in a squared plus b squared, and by taking the square root, we find the c value, if you will. Okay, so that's where your distance formula comes from. Watch your signs. Very often, you're going to be subtracting a negative. Sometimes you'll add negatives. If your signs are wrong, everything will be wrong. So it's very critical that you take care of your signs. Okay, so that pretty much gets us through section 8-9. That's the new material. And it's not entirely new because I know you've had the Pythagorean Theorem before. Everything else should be familiar, or I've written you detailed notes. Again, make sure you look in the book. Make sure that you study, that you look back, and just above all, just do your best. Okay. If you have questions, please contact me, and we'll just try to get through this time together and get you ready to move on into the next units and future years. So I hope you're all safe and healthy, and I look forward to seeing you again very soon. Goodbye.